Yeah, can everyone see this? Okay. So hi everyone. My name is Paige. I am a current 10th grader at Phillips Academy Andover, and as mentioned, I am one of the student directors of the Math Open at Andover, also known as Moaa. Um, yeah, so like it was mentioned, we're going to talk a bit about like the general competition information. I'll talk a bit about like math specifically at Andover, and then we'll go into detail about the contest format, and then we'll end with some past problems. Okay, so what is Moaa? So Moaa is an annual math competition for middle schoolers that we host here at Andover. It's organized by members of our math club, and we have two divisions, the virtual division and the in-person division. Our virtual division is held over Discord and Zoom, like most other math competitions, and we also have an in-person that is held on the campus of Phillips Academy. And our competition is over the course of one day. So math at Andover. We have math club every week. We meet weekly on Wednesdays for an hour, and this includes some fun activities, our like student-led lectures in the winter. It is one of our biggest things, which is every winter, any student can submit a lecture of their choice, and they can choose to give a lecture for like an hour or so, and they will just talk about whatever topic they want to in math. And we also have practices for many different types of competitions like PUMAC, ARML, HMMT. And the photo actually here on the this photo here, this is from HMMT February of this year. And then we also of course, we run the Moaa. We spend the whole year planning it to make sure that it runs smoothly. And yeah, down here, this is our poster for the club fair this year. Okay, so Andover math courses. So Andover offers a huge variety of math courses going from algebra 2 all the way up through to linear algebra. And we also offer a special seminar course called Honors Math Seminar for students who have like maxed out the traditional math pathway. So we use like a numbering system. So our 200 level courses are like algebra and geometry. Our 300 level courses are like pre-calculus. Our 500 level courses are calculus. And like our 600 level courses would be like multivariable calculus, linear algebra, and seminar. So this is a picture on the right of the math progression flowchart. It's kind of small and it looks kind of complicated, but essentially how it works is that the 200 level courses you will finish in a year. Depending on what 200 course you take, your 300 courses could take anywhere from 2 terms all the way up to 2 full years. Your 500 courses could be anywhere from a year to like 4 terms, so like 3 or 4 terms. And then your 600 level courses are generally taken as electives, so it's by term. So yeah, it looks kind of complicated, but it's a lot more simple than you think it is. And then we also have 400 level courses, which is like there's a skip between 300 to 500. Our 400 level courses are like our financial literacy courses, which is like separate, and these are all electives. But yeah, this is like what our math courses would look like at Andover. So now let's talk a little bit about the competition format. So Moaa has 2 individual rounds and 2 team rounds. So we have the speed round, which is an individual round. It's 10 questions in 20 minutes. We have an accuracy round, which is 10 questions in 45 minutes. And then we have the team round, which is 15 questions in 40 minutes. And then finally, we have the Gunga Bowl, which is 9 rounds of 3 questions each for a total of 60 minutes. And teams are made up of anywhere from 1 to 4 people each. So on the right here is what the schedule last year looked like. As you can see, we basically run from early morning to late afternoon, and we have many different events in the middle. We will include like an end of admissions talk, there's speaker events, and there's also we will offer lunch. So yeah, we're gonna go a bit into detail more on every single one of these rounds now. So the speed round. So the speed round is an individual round. Like I said earlier, it's 10 questions to be done in 20 minutes. And all answers are non-negative integers of at most 1 million, and you may not use calculators on this round. So in 2023, we use these weights to score the speed round. So as you can see, the earlier problems are weighted less than the later problems, as of course the problems will increase in difficulty. And to score in the top 20%, you would need a score of, if you were virtual, you would need a score of 17. And if you were in person, you need a score of 11. So I think that's like approximately the first 5 if you were going in person, and like maybe the first 6 or 7 if you were virtual. And yeah, so the next round we have is the accuracy round. So the accuracy round is an individual round made up of 10 questions to be done in 45 minutes. And all answers are non-negative integers of at most of most 1 million, and you may not use calculators during this round as well. In 2023, the below weights were used. So as you can see, we score the accuracy round a little bit higher than we score the speed round, because this round, we focus more, like, as you can kind of tell, the speed round is faster problems. The accuracy round, you have to kind of be more accurate. But yeah, so the accuracy round, the problems are scored higher. And to score in the top 20, you need a score of 20 if you were virtual and 12 if you were in person. And I believe the median score this year for accuracy was 6 for an in-person and 7 for virtual. So yeah, as you can see, the problems aren't meant to be done. You're not meant to be able to solve all 10 problems. Most of the time, scoring anywhere between 5 to 6 is good enough to score you in the top 20. Next up, it's the team round. So the team round is, like I said earlier, 15 questions to be done in 40 minutes. And all answers are non-negative integers of at most 1 million. And of course, you may not use calculators, which is a common trend throughout our entire competition. And so like I said earlier, in 2023, we used the below weights to score the team round. As you can see, it starts off like, as you can see, the scores, the weighting like increases significantly towards the end. So solving problem 15 is 10 times as important as solving problem 1, but it's also like definitely 10 times more difficult. So to score in the top 20, you would needed a score of 100 in virtual, and an in-person score, you would have needed a 50. Okay, now for Gunga Bowl. So the Gunga Bowl is a team round made up of 9 sets of 3 questions to be done in 1 hour. This is kind of similar to those of you who've gone to HMMT. This is very similar to their GUS round, where you basically, once you submit a set of responses, you may not resubmit it ever again. And you cannot receive the next round until you submit the round you are currently working on. All answers are non-negative integers, and you may not use calculators. So in 2023, we used the weights below to score the rounds. These are rounds. So each question in the round was worth 8 points for a total of 24, 30, 36, etc. And so to score in the top 20 of the Gunga Bowl, you would have needed a score of 152 if you were virtual and 103 if you were in person. So as you can kind of see, it's very rare for someone to finish a majority of the questions on these tests. They're all meant to be very difficult, and it's often very good to be able to just even do the first half well. So yeah, we definitely prioritize accuracy, I think, in this competition. Yeah, and here are just some tips for Moaa in general. So just first off, it's very, very important to check your work. The score margins between like 20th place, 21st place, 10th place, it's all very, very small. So every small mistake you make could make or break where your final placement is. And another one would be focus on the first half of accuracy. So like I mentioned earlier, accuracy, you have a lot of time. You have 45 minutes to do only 10 questions. The questions are like significantly harder than the questions in the speed round, but just getting the early half right will significantly improve your chances of placing. And it's often like not worth looking at like the last few questions just because it's they're much harder than the beginning few questions, and it's not that much more that many more points. Another tip, the last round of Gunga is generally an estimathon round, which basically means that it's not actually solving math. It's kind of like you're like estimating, which is very similar to what GUTS does in HMMT. So I think as just a general idea, it's a smart idea to try to get to the last round of the Gunga, because that's where you can easily get points from estimating. And also, as another side note, I think in person is better than a virtual, just because of travel. The virtual competition is always more competitive than the in-person competition. So if you can travel in person, I think it's always less competitive in person, and it's much easier for you to place. Yeah, so I'm gonna turn it back over to our host to talk a bit about the example questions.
Sorry, I was muted. So we have this problem. It's the second problem of the sprint of 2023. Uh, and then sorry, wait, can you wait? Um, so yeah, we can solve for the equation of the line and then solve for C based on the line, though it will involve many messy fractions, and I can show you what it will look like on the next slide. Um, so that's what it looks like. You can see that there's a lot of messy fractions. And then since calculators are not allowed, you're probably going to make a small mistake somewhere. Uh, so it would ruin the entire calculation if you made a small mistake, and you would not get like any points for that. So there's a better method. By making an observation, you can see that the 2 points are roughly the same distance from the x-axis. And if you take the average, you can see that it's the average is x equals 1, which means the midpoint is on our desired line where x equals 1. Therefore, we can just take the midpoint of the two given points and it will be guaranteed to be on the line. So a few key takeaways is that you could, if you make like good observations, you can simplify problems a lot of times. And if you can find a pattern in no, given numbers in a problem, they can also simplify the solutions to problems. Okay, so for our second example problem, you can read the problem here. So a pretty simple method that you could do is writing out all the 2-digit numbers and testing each one to see if it works, but that is a lot of work. So basically, we can write the number AB as 10A plus B, and we define the new integer n so that those two equations are true. And then now we have a math problem that we can use like tools with math to solve. And basically, if we think about it, we might want to isolate one of the terms, except it's a lot of terms remaining. We'll end up with 4 terms in total, no matter what. So it's not going to work. So if we do this thing called a variable substitution, we can uh make it very much simpler. And if we have C equals A plus B, then you can make the first equation into 2 terms. Except the problem is now we have 3 variables, so we can do some substitutions to make it just that the first 2 only use C and A. So after simplifying, we have this equation. I'm just saying that you could have defined C in another way, except this is just the simplest way. So now that our first equation is pretty simple, we can use the GCD and the Euclidean algorithm to simplify the second one, except we have to use it backwards in order to be able to use it. So you can see that if we let x equal a and let y equal c, we can use the Euclidean algorithm equation in the reverse order in order to simplify the second equation. Can you click on this one? So yeah, once we get to here, you can pretty easily see that C is supposed to be a factor of 9 since A and C are relatively prime and C has to be divisible by 9A. So we need to find how many pairs of numbers are relatively prime and have a sum that's a factor of 9. And now this is easy to count because C has to be 1, 3, or 9. And if it's 1, there's no solutions. If it's 3, there are 2 solutions. And if it's 9, you can just write them out and see that there's 6 solutions. So we end up with a final solution of 8. So basically from this problem, you can see that word problems are usually harder to solve than math equations because you don't have tools that deal with it. So if you can turn a complicated word problem into a math equation, it usually makes it simpler. And variable substitutions can make dealing with more complicated expressions a lot easier. And some tools that you normally use in one way, you can use backwards. For example, the Euclidean algorithm from this problem. And now I'm going to turn it over to Kenan to explain a few more difficult problems.
All right, so hi. First, we're going to talk about 2023 accuracy round number 7. So this problem says that pentagon A and D prime Y has AN parallel to DY and side length AY parallel to D prime N, with AN equals to D prime Y and AY equals to DN. And if the area of quadrilateral ANDY is 20 and the area of quadrilateral AND prime Y is 24, and then the area of triangle ADD prime is 26, the area of ANDD prime Y can be expressed in the form M over N for relatively prime positive integers M and N, and we want to find M plus N. So the first thing we do to this problem is we draw a diagram, of course, since it's a geometry problem. So the trick to the problem is we use the fact that when two triangles have the same base, the ratio of the areas is the same as the ratio of the heights, and we could swap the areas and heights. And then we could use this to set up an equation. Next slide. So, okay, first thing, we construct the auxiliary point. So let's let X be the intersection of D prime N with the YD. We first noticed that quadrilaterals ANDY and AND prime Y are both isosceles trapezoids due to the conditions of AY and D prime N being parallel and the equal sides. So therefore, since these two quadrilaterals are isosceles trapezoids, we know angle D prime YA is the same as angle YAN, and angle YAN is the same as angle AND because of the isosceles trapezoid condition. And then because of these two equations, angle D prime YA is the same as angle AND. Also, notice that AN equals D prime Y because that was what the problem told us, and YAN, and AY equals ND. So therefore, we get triangle AYD prime is the congruent to triangle DNA, which is congruent to NAY. Well, due to SAS similarity, because we have two sides that are equal and the angles between them are also equal. Now we have to set up a variable as we want to find the area of A and D prime Y. So let's let A be the area of triangle AYD prime. We get the area of quadrilateral ANXY is 2A because it's a parallelogram and triangle ANY has area A. So we get this area as 2A. Also, when we take the area of yx as d prime, this is 24 minus 2a because the area of a and d prime y is 24. And we know the parallelograms a and xy's area is 2a, so we get 24 minus 2a. And then we know that ay is parallel to d prime x. So by the condition, we have ax d prime is equal to the area of triangle yxd prime, which is both 24 minus 2a. Similarly, by the same logic, the area of triangle AXD is the same as 20 minus 2a. We also know that the area of d prime xd is the same as the area of AD prime minus ADX minus AD prime x. So if we calculate this, we get 4a minus 18. And then let's take the area of nxd divided by nxy. So here we use the trick since they have the same height, then we know the ratios of the areas is the same. as dx over dy because the bases. So anyways, this is d prime xd divided by d prime xy. So this is 20 minus 2a over a by plugging in. And then we also have 4a minus 18 divided by 24 minus 2a, which is 2a minus 9 over 12 minus a. So we cross multiply this equation, we get this. And then we moving terms and we cancel out 2a squared. We get 35a is 240. So a is 48 over 7. And also remember our problem statement was that we had to find a and d prime y. Breaking this thing up, we have 2a plus the area of triangle ADD prime, which is 2a plus 16, which is 278 over 7. Final answer is m plus n, which is 285. And we're done with this problem. All right, our next problem is, well, also from the accuracy round, number 8. So this problem states that Harry wants to label the points of a regular octagon with the numbers of 1 to 8, and same thing with the edges. And he has to follow some rules while labeling the points and edges. So in other words, the edge is basically the same parity as the sum of the 2 points connecting it. Okay, then two octagon labelings are the same thing if they are equal when you rotate them, but if you reflect them, the labelings are still considered different. So in other words, reflection matters, but not rotation. If n is the number of possible octagon labelings, find the remainder when n is divided by 100. So for this problem, we don't really care about the numbers. We only care about the parity, as that's what our condition is. So we could interchange 1, 3, 5, and 7 because they're all odd in 2, 4, 6, 8. So we only consider where odd numbers are and where the even number are. All right. So let's assume that rotating the octagon actually matters, giving us distinct configurations. And then in the end, we divide by 8. So let's look at the numbers on the vertices. So when two consecutive vertices have different parities, we know the edge is the same parity as the sum of the two vertices. So it should be labeled as an odd number. And otherwise, if the two parities are the same on the two consecutive vertices, then the edge should be labeled even. The numbers on the edges are 1 to 8 because that of our condition. And between those numbers, we have 4 odd edges and 4 even edges. This means the parity of the vertices switches 4 times because remember when the vertices parity switch between consecutive vertices, then we have an odd edge. So in other words, it switches 4 times. So we have a group of even numbers, then we have a group of odd numbers, and then another group of even numbers, and then odd numbers as shown in the diagram. For the two groups of odd numbers, either both of those groups have 2 numbers as shown on the bottom right diagram, or one group has 3 numbers and the other group has only 1 number as shown in the left diagram. And then same thing for the groups of even numbers, although I only drew both groups having 2 numbers. So we have 4 cases, although 2 of the cases, which is with the even numbers are both split up 2, 2, and the odd numbers are both split up 2, 2. Those 2 cases are the same thing, so we merge them. All right. So this is our first case where all of the groups have only 2 numbers. We have to decide where the odd and even numbers are on the octagon, but looking at the diagram, we could just rotate it by 8, but then we have to divide by 2, which gives us 4 because it's symmetric. And then the odd numbers are interchangeable, as we said in the beginning, like where 1, 3, 5, 7 are doesn't matter, as well, I guess we could switch them around. And then we have 4 factorial to decide where the odd numbers are and 4 factorial to decide where the even vertices are. And also we know the parity of the edges if we know the parity of the vertices. And same thing with the edges. Oh, the parity does not matter. I mean, the parity is the only thing that matters on the edges, as long as we can switch the numbers. Like, for example, we could switch a 1 and 3 on the edges, and like 2 and 6, I guess, on the edges also, as long as they're the same parity. So we get 4 times 4 factorial to the 4th power, which is 4 times 24 to the 4th. All right, the second case is when both of the groups, actually one of the groups, two of the groups have 1 and 3 numbers, but the other two groups both have 2 numbers. So as in the diagram, the odd numbers have a group of 3 odd and 1 odds, but the even ones are both 2 numbers. So without loss of generality, let the two groups with 1 and 3 numbers be odd. Well, it could also be even, but like let's just assume the evens are split 2-2 and the odds are split 1-3. Then we have to decide the order in like where we put the odd and evens, because we could rotate the octagon. So we look at the odd group with only 1 number. So where this group is located, we could decide where the rest of the groups and numbers and parities are. So there's 8 ways. And as again, 4 factorial times 4 factorial to decide which even numbers actually go into evens and which odd numbers actually go into the odd numbers. So as again, we always have 24 to the 4th power times 16 to decide where the parities are. Great. And then the third case is when both of the groups are split 1-3, both of the parities. And then so here we have one even group with only 1 number and one group with only odd number. And then the other 2 groups have 3 odds and 3 evens. So we want to order this. So similar idea, we only look at the groups with only 1 number, but either the even number is to the left of the odd number or to the right of the odd number. Once we decide it, there's 2 ways. And then there are 8 ways to place the 2 numbers once we decide whether like even is to the left of the odd or even is to the right of the odd by rotating the octagon. And then as always, 4 factorial to the 4th to place numbers on the edges to the vertices rather than just having evens and odds. So we get 2 times 8 times 4 factorial to the 4th power, or 16 times 24 to the 4th. Okay. And then now we have all the cases. We take 4 times 4 factorial to the 4th plus 16 times 4 factorial to the 4th plus another 16 times 4 factorial to the 4th power. Then this is 36 times 24 to the 4th power. Now we also, well, in the beginning, we said rotation does matter, but in our problem, it actually doesn't. So let's divide by 8. In the end, we get our n is 9 times 24 to the 4th divided by 2. So here, n is obviously a multiple of 4 actually, because there are many factors of 2 in its prime factorization. But also, n is congruent to 9 over 2, which is 9 times 2 inverse of 2, which is 17 mod 25. Because we take 24, which is -1 mod 25, but this to the 4th power is 1 mod 25. So yeah, we get 17. And then by Chinese remainder theorem, n is congruent to 92 mod 100, because like we can just guess like n is 0 mod 4 and n is also 17 mod 25. So we get n is 92 mod 100, and that is our final answer.
Okay, perfect. Thank you so much, guys. I'm gonna open it up to questions now. So if any of you guys have any questions, you can feel free to leave them in the chat and I'll answer them. The slide for the individual round, yeah. Let me. Okay. Yeah, so we have two individual rounds, like I mentioned earlier. This is the speed round, and then we have another one, which is the accuracy round. Do you guys want to see the accuracy also? Accuracy. Okay, the question. It says how many people participate in in-person and virtual settings. I think we had a couple hundred kids last year in person. We almost always have more kids virtual than we have in person, just because, like I mentioned earlier, it's very difficult for students to have to travel all the way actually to Massachusetts. So I think it was a couple hundred online and like 100 or so, like 100, 200 maybe in person.
For
But it's
2020,
definitely, sorry, go ahead.
yeah, for 2023, it was like 150, I think, just looking at the stats.
Mhm.
And for virtual, yeah, 150 in person. For virtual, like over 200.
Yeah, so it's almost always more competitive online than in person. So no, you don't have to participate as a team. You can go anywhere from one, like to one, from anywhere from you can compete individually up to a team of 4 people. If you also want to go individually and you want us to put you in a team, there's also an option we can make teams for you where we will basically, if you choose to, we'll combine a bunch of individuals together to make a team. But you can also participate individually if you want to.
Okay, if there's no more questions, then we can wrap it up here. Thanks Paige for just doing this talk for us, just like being a guest speaker, and that's pretty much it. Alright. Bye.
Yeah, thank you to everyone for coming and listening to this talk. I really appreciate all of you guys being here, and I look forward to seeing all of you at Moaa this year.
Good luck on Moa if you decide to do it.
Yeah, thanks for attending.
Oh, for the registration, we open registration, I think, in like the late summer or early fall. So it's not going to be out yet for a while, but it will be out and then there will be an email sent to everyone.